Dear students, let us solve some numerical problems related to acoustic phenomenon. At first, let us review the related formulas. First, Doppler's effect. If source of sound is moving with velocity us and observer is moving with velocity uo, v is the velocity of sound in air, and f is the frequency of sound produced by the source, then the apparent frequency heard by observer f dash is given by the relation b minus uo upon b minus us into f, where source and observer are moving in the same direction according to this relation. Now it is noticeworthy that the velocity of sound coming towards the observer is always taken positive. So this is the positive direction of sound. Next, Doppler's effect due to echo. Reflector wall or tunnel cliff acts as source of sound. Next, if L1 and L2 be the loudness of sound produced by a source at distances R1 and R2 in decibel, then L2 minus L1 is equal to 20 log 10 R1 upon R2, which is difference of loudness in decibel, which is abbreviated as dB. Loudness of sound in decibel is given by the relation L is equal to 10 log base 10 I upon I naught, where in decibel, where I naught is equal to 10 to minus 12 watt per meter square, which is threshold of hearing. Inverse square law for sound is I is inversely proportional to R square. Therefore, I1 upon I2 will be equal to R2 upon R1 whole square. Question number 1. A stationary motion detector sends sound waves of 150 kHz towards a truck approaching at 120 km per hour. What is the frequency of the wave reflected to the detector? Velocity of sound is 340 meter per second. Solution here. Given, suppose this is stationary detector, UO is 0. It is producing sound of 150 kilohertz frequency, which is reflected by a truck. This is truck coming towards the detector with speed, because sound coming towards detector will be along this side, therefore this will be the positive direction. B is 340 meter per second velocity of sound. This is acting as source due to echo, therefore U of source will be equal to 120 km per hour, which is equal to 33.33 meter per second. Now we have to find the apparent frequency detected by the detector. Now f dash is equal to b minus us, b minus uo. F dash is equal to b minus uo upon b minus u s into f. Values are known. B is 340 UO is stationary 0, 340 minus 33.33 into F is 150 kilohertz. On simplification we get 166.3 kilohertz. Question number 2. A train approaching a tunnel in a cliff face at 25 meters per second is sounding a whistle of frequency 800 Hz. What will be the apparent frequency of the echo from the cliff heard by the driver? Now solution. Here given this is the truck, sorry, this is train. Coming towards a tunnel cliff. So the driver of the train will listen echo sound coming towards the train. Its velocity is given to be 32 meter per second. Velocity of sound in air. Velocity of train is given to be 25 meter per second, because this is moving in opposite direction with respect to the velocity of sound, therefore its value will be negative. F is the frequency of sound produced by train, 800 Hz. We have to calculate apparent frequency. Apparent frequency of sound from echo heard by the driver. Now F dash is equal to V minus UO upon V minus US into F. Values are 332 minus 25 upon 332 minus given this is the train moving with velocity u equal to 25 meter per second and producing sound of 800 Hz frequency. This sound is reflected by the tunnel cliff. So that its mirror image of the train will act as source of sound. So its value will be 25 meter per second. Velocity of sound coming towards train will be 332 meter per second. This will be acting as observer. Driver of the train will be acting as observer, and its velocity is opposite to the velocity of direction of velocity of sound. Therefore, it must be taken negative. F dash is equal to B minus UO upon B minus US into F. Put the values. B is 332 minus UO is minus 25 and 2F 800 upon 332 minus 25, which gives apparent frequency as 930.3 Hz. In case 1, in first case, when car 2 is approaching car 1, then this will be the case. This is car 2 will be acting as observer. This is car 1 acting as source. Velocity of sound coming towards the observer will be in this direction 340 meter per second. UO 80 kilometer per hour, which comes to be 22.22 meter per second. Similarly, US is given to be 60 kilometer per hour, which comes to be 16.67 meter per second. With respect to the velocity of sound, both are in opposite directions, therefore UO will be minus 22.22 meter per second and US will be equal to minus 16.67 meter per second. Therefore, apparent frequency will be equal to V minus UO upon V minus US into F 340 minus UO 22.22, that's 22.22 upon 340 minus 16.67 into 500, which will give 507.7 Hertz. In second case, when car 2 overtakes car 1, this is car 1, this is car 2. Car 1 is source, US, this is observer, UO. Sound is coming towards this side, therefore with respect to its direction both are positive, so US will be equal to 16.67 meter per second and UO will be equal to 22.22 meter per second. As we know, the direction of velocity of sound is always taken positive. So all these two velocities are along V and therefore they are taken positive in this case. Therefore, F double dash, which is new apparent frequency, will be V minus UO upon V minus US into F 340 minus 22.22 upon 340 minus 16.67 into 500, which gives 491.4 Hertz. Next, question number 4. A car traveling at 20 meter per second blows a horn of frequency 600 Hertz towards a stationary observer. Find the change in apparent frequency heard by the observer when the car approaches and then overtakes the observer. Velocity of sound is 330 meters per second. Solution first case, when the car is approaching, stationary observer. This will be the case. This is stationary observer, UO is 0, observer, and this is car moving with velocity. This is source with velocity 20 meters per second, producing sound of frequency 600 Hz. Velocity of sound is coming towards this side. B is 330 meters per second. With respect to this velocity, this is positive. Therefore, apparent frequency heard will be B minus B UO upon B minus US into F. B 330 minus 0 upon 330 minus 20 into 600, which gives apparent frequency as 638.7 Hz. When the car overtakes stationary observer, then the case is like this. This is stationary observer, UO is 0, and this is car moving with velocity US as 20 meters per second. Sound is coming towards this side, towards observer, B 330 meters per second. With respect to the velocity of sound direction, this is opposite, therefore it must be taken negative. Therefore, apparent frequency in this case will be B minus UO. B minus UO upon B minus US into F. B 330 minus 0 upon 330 minus 20 into 600, which gives 565.7 Hz. Therefore, the difference between two apparent frequencies will be equal to F dash minus F double dash, which is 638.7 minus 565.7, which is 73 Hz. Next, question number 5. A car is moving away from a stationary listener with a velocity 20 meters per second. If the horn is sounding at 512 Hz, calculate the change in pitch of sound received by the listener. Solution here given. Suppose this is observer or listener. Which is stationary. This is car. Going away from the stationary listener. So the sound will be coming towards this side. Velocity is 330 meter per second. Frequency is 512 hertz. And its velocity will be negative 20 meter per second. S will be equal to minus 20 meter per second, because this is opposite to the direction of the velocity of sound coming towards the listener. So apparent frequency F dash is equal to B minus UO upon B minus US into F 330 minus 0 upon 330 minus 20 into 512, which gives F dash as 482.7 hertz. Therefore, change in pitch will be equal to actual frequency minus apparent frequency, means F minus F dash, which is 512 minus 482.7, which is 29.3 hertz. Next question number 6. An observer traveling with constant velocity 20 meter per second passes close to a stationary source of sound and notices that there is change of frequency of 50 hertz as he passes the source. What is the frequency of the source? Solution. Given. In first case, when observer is, this is observer moving towards a stationary source. This is source. US is 0. Sound is moving towards this side. B is 340 meter per second. Observer's velocity UO will be equal to, its direction is opposite to that of B, therefore it will be negative 20 meter per second. And in case 2, when the observer passes the source here, when the observer passes the source, then in this case velocity B will be equal to 340 meter per second in the direction of UO, therefore UO will be equal to plus 20 meter per second. So we have delta F is 50 hertz, then F will be what? In first case, when the observer moves towards stationary source, then apparent frequency f dash बराबर b minus uo upon b minus us into f b 340 minus 20 upon 340 minus 0 into f f dash will be equal to 360 upon 340f 0 cancels, which is 18 upon 17f. And when the observer passes the source, then new apparent frequency f double dash will be equal to, from this diagram, b minus uo upon b minus us into f gives 340 minus 20 upon 340 minus 0 into f. This is 320 upon 340f 16 upon 17f. Therefore, change in frequency will be equal to, therefore, delta f will be equal to f dash minus f double dash. F dash is 18 upon 17, f is common, delta f is 50, 18 upon 17 minus 16 upon 17, this gives 50 is equal to 2 upon 17 f. Therefore, f will be equal to upon 2 means 425 Hertz. Next, question number 7. A source of sound generates sound waves which travel with the speed of 340 meter per second. The frequency of the source is 500 Hz. Find apparent frequency if, in first case, source is moving towards a stationary observer with velocity 30 meter per second. Second, when observer is moving towards a stationary source with velocity 30 meter per second. Third, when both are moving with the velocity 30 meter per second approaching each other. Solution. First, when source is moving towards a stationary observer, source is moving towards stationary observer. This will be the case. Source us is 30 meter per second. Sound will be moving this word 340 meter per second. Observer is at rest, stationary. Frequency produced by the source is 500 Hz. Therefore, f dash will be equal to b minus uo upon b minus us into f 340 minus 0 upon 340 minus 30 into 500, which gives apparent frequency as 548.4. First case. Now in case 2, when observer is moving towards stationary source, that is, source is stationary, this is source, velocity of sound will be towards this, and observer is moving, this is observer, with velocity 30 meter per second. Because its direction is opposite to the direction of velocity, therefore it will be negative. Therefore, f dash will be equal to b minus uo upon b minus us into f, that is 340 minus 30 upon 340 minus 0 into 500, which gives 540 hertz, 44 hertz, 44 hertz. In third case, when both approach each other, moving with velocity 30 meter per second, then the case will be like this. us is 30 meter per second, velocity of sound will be towards this 340 meter per second, and observer is moving towards this side. uo is 30 meter per second, but it is opposite to the velocity of sound, therefore will minus, it will be minus. Therefore, apparent frequency b minus uo upon b minus us into f gives 340 minus 30 upon 340 minus 30 into 500, which gives apparent frequency as 596 hertz. Question number 8. The intensity level at 10 meter distance from a loudspeaker is 100 decibel. What will be the intensity level at distance 200 meter? So, solution to question 8. Given when R1 is equal to 10 meter, then loudness, also called intensity level, will be 100 dB. We have to find L2 when R2 is 200 meter. We know the difference of two intensity levels in decibel is given by the relation L2 minus L1 is equal to 20 log base 10 R1 upon R2. So it will be 20 log base 10 R1 is 10, R2 is 200. It gives minus 26.02 or nearly minus 26. L2 minus L1 is 100 will be minus 26. This gives L2 as 100 minus 26 means 74 decibel. Next question number 9. When a jet plane is flying at an elevation of 1000 meter, the sound level on the ground is 4 decibel. What would be the intensity level on the ground when the elevation is 100 meter? Solution to question 9. Given L1 is 4 dB when R1 is 1000 meter. L2 will be what? When R2 becomes 100 meter. Again, we know L2 minus L1 is equal to 20 log base 10 R1 upon R2 in decibel. Therefore, L2 minus L1 is 4 will be equal to 20 log base 10 R1 is 100, R1 is 1000 and R2 is 100. So 20 log base 10 of 10, which is 20. Therefore, L2 minus 4 is equal to 20. It gives L2 as 24 dB.